Welcome to our presentation from Goteborgs Tekniska College in Sweden. We have been a part in this project, Innovation Garage of Garages, and we have here in Gothenburg been running a project with Volvo Cars in education and coaching of the engineers of Volvo Cars mainly. My background, I'm an old consultant, been working in the industry for 30 years, give or take, and been working in lean production and even so in economic consultancy as well as a financial risk manager. So that's my background. And as I said, we started this project in 2019, and I will give you a brief summary of the contents of our courses. So we have a suite of electromobility courses, and the background, why are we doing this? It's to answer those main questions concerning the transformation of the industry towards electrified vehicles. And of course, the first one, what is happening? What is happening on the market? What's the background? And so on. Why is it happening? Why is this taking place now? When is it happening? Where is it happening? All over the world is a good answer to that one. Who does it affect? How will it happen? And perhaps the most important question of all, why participate? What's in it for me? And old combustion engine oriented vehicle engineers has to be persuaded into migrating into this new reality. There is the internal combustion engine is usually abbreviated as ICE and ICE, and of course it's ice cold. So there is no future in the further development of combustion engine vehicles. So how to persuade or invite engineers to take part in this development with their vast and extensive knowledge of vehicle technology and contribute to this transformation instead of being opposed. So we have during 7 days, 56 hours of courses. The first one is an awareness course, a rather superficial bird's eye view on this transformation in groups of 32 people, 4 hours as I said. There are a section about environmental impact of internal combustion systems, market development, the total cost of ownership of electric vehicles contra standard combustion engine vehicles, technology and so on. And then these groups are divided into groups of 16, where we have a mix of theory and practice during 8 hours, battery system overview, a hands-on course where the participants gets to handle the vital components of an electric vehicle and looking at diagnostics and so on of battery systems. Battery technology, electrical safety, battery management. It's a sensitive piece of equipment, so it needs governance. Usage and durability of battery systems. So that's a 8-hour course for those 16 participants. And then I usually do the first course and the third, this one, a lithium-ion battery system. 16 hours, 2 days of theory and practice, battery cell formats, physical chemistry, supply chain, system design, production of batteries and so on. EV charging and power supply, a 12-hour, 1.5-day course in modes, different charging modes and the behavior of charging systems, the infrastructure, business models, power consumption and so on. And the 5th course, electrical machines and transmission, another 16-hour course, drives overview, hybrid powertrains, topologies, circuit theory and so on. Battery cells, they are, especially lithium-ion battery cells, are highly sensitive. They need to be run at the right conditions. And those conditions are, in this example, depicted as the right voltage. If you are going below a critical limit or above a critical limit, roughly 2.2 to 4.2 volts for standard NMC cells, you get into trouble. And you have to keep the temperature stable as well. So below -20, which happens in Sweden, you run into problem. You need to heat the battery, but you have to prevent it from increasing above +80 degrees. And the standard working temperature of 30 degrees is hard to get, and it needs powerful electronics to maintain the battery within that narrow window of operation. So we in the course we are discussing and looking at what is the cause of those different scenarios. What happens if overcharged? What happens if the temperature is increasing, and so on. Lithium ion cells, they don't die, they get murdered. It's an often used quote. So nasty things happens, and everything needed for a full-blown fire is present within the battery. You have fuels, you have heat, and you have oxygen present. So yes, you could run into problem, a runaway fire in a battery cell. There are advancements in battery chemistry where we are using new materials, and graphite has been the gold standard of lithium-ion batteries for a good many years now. But substituting graphite for silicon or pure metallic lithium, you will have a tenfold increase in energy density. So that large Tesla battery of 640 kilos could reach perhaps 60 or 70 kilos. So it would be a vast improvement to use a high energy dense battery. So the transition now present on the market from standard battery cells where you have liquid electrolytes, you have a separator, you had anode and cathode material, into solid state batteries. Solid state batteries are inherently more safe than those using liquid electrolytes. You won't have any leakage, it's more robust, you could produce them in any shape or form required. It's much simpler fabrication and so on. So the investments being done in the recent battery factories, they could easily be modified in producing solid state batteries instead. So those are some of the topics we are covering in our courses. And why are we doing this? We get comments from former participants. It was great. The most common comment we get is, it was great. I finally understand what my colleagues are talking about. So by sharing basic concepts, sharing a language, engineers get to exchange experience from different areas. And that's where the magic of engineering happens, at least to my experience. So it's a good thing to get a understanding of what happens within the battery, and to be able to share your experience with your colleagues. That is perhaps the most critical outcome of this course, I think. The greatest benefit for Volvo Cars. So then, if you wish, contact us in Gothenburg from Goteborgs Tekniska College, and see if we could assist you in your efforts in the journey of electrification of the vehicle fleet. Thank you.